Hi, my name is Milan, and today I will look at the dice. You'll see on the screen we got going a little bit already. Just want to clean it out a bit. I lost keep of count. I lost count a little bit. Fortunately, I recorded the dice, so we can rerun it again. You'll see on the screen what I have is currently, well, there's the video that's going to show the dice on the top left hand side and the top right hand side. On the left hand side of the screen, that's the perfect target. So I'm going to try and throw the dice 600 times, and then that will be the perfect distribution. On the right hand side, that's how I'm going to keep track of the actual that was thrown, and in the middle, there's the count with some percentage as well. So yes, let's get going. And for that, I have to start cleaning up the figures. So let's just do that. The actual figures on the left hand side. See, I've got space for 600. And that's where we're going to keep tab on that. And then on the left hand side, in the middle, you can see the counter going. Okay, so let's let's have some fun. Okay, the first one is ending up in a 1. It's a 5. 6. Another 6. Okay, where's our 4? Ah, there's our 4. Okay, be kind enough, you can share some information you might have. Normally the question will be, what must the sample size be? How many times must I throw this dice before I actually will start having a good distribution here? Because that might be quite a interesting question. Okay, I just want to scroll this up and down a little bit. I can see not the current one. Let's just move it up and down a bit. We see the latest. I want to show the latest one that was thrown. Okay, 20. Okay, let's continue. Shame, poor 4. Poor 3 is now struggling to catch up. Wow. It's not going too slowly, but yes, we still have a lot. Far way to go. I just want to throw that one. I'm right-handed, so I'm throwing with my left hand. Maybe I should switch it up at some stage. Okay, so it's not bad. Percentage-wise, it's probably looking pretty okay for now. the 4 caught up well, so you can't be careful not to think you can predict the future. But we need a lot of 3s, so there we go. These 3s catching up a little bit. Wow, 4s. I want to, of course, keep some of the data also in Excel. Just for curiosity, I might want to go back and pick up something. But I know statistically, it's just a question. It's 1 out of 6, basically. Throwing the dice. So there should be a 1 in 6 chance of trying it. But then making complicated will be the question of when will the distribution be even. At this stage, it's just the 3 that's got off. Okay. I'm going to quickly see if I can add a percentage in here. Because that to me a bit easier for many of us to follow. Just get there. Okay, next one, a 4, 5, 5, 1, 4, 6, 3. Yes, I think I prefer the percentage to show up here. Yay, we reached 100. One, 4. I'll try at some stage make a video and just to speed it up a bit as well. Yay, a 3. Special number 3. But for the sake of science, yay, 3. I'm going to be happy every time I see a 3. Okay, quarter away there. Rooting for number 3. threes are coming. Crazy. Now we probably have to root for the number 2 again. Three. So in the start, you probably would have said there should be a lot of threes still coming if you initially said this. So before we did the 190th trades, you probably would have look in the future, say yes, 2 and 3 will catch up still. So at this stage, you want to almost bet on a 2 and a 3 here. But on my mind, it doesn't work. It doesn't necessarily work that way. Again, that might be where the science comes in to say, I want to almost say, should you bet now on 2 and a 3? You almost want, because it feels very scientific. It feels almost scientific that the 3s and the 2s must catch up. Oops, that was a 5. Sorry about that one. That was a 5. Another 5. 1, 4, 4. Come on, 3s. The scientific question would be, how many times must you throw the dice for it really to become even? And I think it's a lot. It might be more than 1,000. We're going to throw 600 times. So we can already see, or unfortunately see now at this stage, if you look at the figures, the high is 19. And the lowest being 14%. So that's quite a difference. So we need at least that number of throws to catch up. Of course, we will not throw like 10 threes back to back. That's very unlikely. You can, at the end look at how often it can happen that you have a streak. I think call this more empirical data, where you look at actual events than science, but it's still fun. to see it in real terms and not just on paper. Between the 2 and 3s, they're the slow ones. Of course, we're not halfway yet, so the tables can turn completely. Oops, that was a 3. No board games for me tonight. I'm gonna have to rest my throwing arm. Oops, 6. Oops, that was a 6. Sorry about that. Number 1. Okay, we're halfway. Okay. Ooh, take a bit of a breather. Look at this streaming, if it's still going at least. Yes, I'm going to definitely upload. I think it's fun for me to do this one, so I definitely want to upload it at some stage again. Okay, so I just want to transition. Sorry about that display, which was a bit wonky. Let's do a couple more. Okay, 4. Oh, sorry about that one. 3. Oh, sorry, it's 600. So if I make an inaccuracy or there, please forgive me. Maybe I'll go back later and fix it up. Of course, if I finish with these throws, I cannot continue at a later stage and just add it to the data. I should probably restart completely. So I hope with my number of 600 that it's going to be enough. Oops, that was a 4. Sorry about that. 4 and then a 6. Oops, that was a 1. Of course, sometimes we want to throw as wild as possible. That's we're sometimes losing the dice. Oh, come on, sorry. Yay. Like I see the poor 3 is still lagging. Wow, there's a 4 streak. getting there. So it's not an impossible task. Yo. Oops, that was a 2. Oh, there's a couple of 3s coming through now. So still the difference between top and bottom is 14% and 19%. Of course, not a crazy difference. So at 500 still haven't evened out. I want to guess you almost have to double up the number of rows you still have to do to get an even distribution. You have to really, I think, throw a couple of thousand times or even 10,000s of times for it to even out. For that, you can probably, as a quick way to check it, you can probably use Excel and put in a random function and play around with that as a fun maths activity. And then go to formulas if you want to really figure out. I think it will be to do with sampling size. To predict how many times you must throw this. 2, 5. Yeah, I'm so glad this is possible to do. Oops, the end coming up. Only 15 more times. And then please leave a lot of comments and likes. You might tempt me to try it again. Maybe play it a couple more times. Give me the signs. I'll definitely keep to try it out. But no, 3 is not going to catch up. That I can promise you. We'll try. It might catch up with 2, but surely cannot catch up with the higher throws. Voila. Okay, we're done. Okay. Okay, so actually I think the counter is a bit off. I just want to quickly check there and see if my Okay, so that was pretty much it. I hope you enjoyed that. I lost track of count a little bit, but initially, I think the error margin is probably just like one, let's say 5 out of 600. I might have messed up, but generally, I think it's quite a good experiment. Hopefully enjoyed this. Try it back at home as well. Let me know how things are going, and hopefully you have a nicer distribution that I have. But actually, you don't want the best distribution, then it makes it more fun. Also, go play around in Excel a bit, see how many you might need to get it nice and even distributed. I think it's going to be in the thousands that you need for this to be evenly distributed. I might even quickly do that just for the sake of our viewers. Let's see if I can quickly do that. Let's see if I can get my Excel up and running with random. Okay, so there's my counter. Of course, the counter, I have to set it now to random. I have saved the data, so it's not supposed to be a big problem. So I'm just going to quickly say, I hope I'm going to get it right. I think it's going to be equal random if, and then random if, let's see if I can get some help. I think random if it's going to have an upper and a lower. And I think it's going to be 1, 6. Let's see why I messed it up. I think, no, it's not random if, it's ran between 1 and 6. Okay, it's a random between 1 and 6. Just have to run that all the way down. But now, of course, if I take that random all the way down, I have to increase it quite a bit. So let's see if I can increase it. Let's just run it down all the way. I'm not sure. Quite far down. Let's take it. I'm probably going to take it to 1,000. Let's say 2,000. I think you're probably going to need 10,000 to be evenly distributed. And of course, there's some maths behind this as well. So please, if you, from a statistical point, know the formulas, share it with the group. Maybe at some stage I also can try and do the maths. It's running down. Let's see if it's running all the way down. Of course, now I have to just go correct here my middle section, because the range is now not going to be 600, it's going to be 2,000. And let's see if I can copy and paste some of these. I missed one, but that's fine. It's 1,999. And the lowest is 15%, high 60%. So, so it's sort of getting there. If I look at my spreadsheet where I missed my count, let's see if I can pick up where I missed my count. It's supposed to be running from actually cell number 2. I think actually running from cell number 3. That's my, I think, cell number 2. No, it is my cell number 2 up until cell number. I did miss one. Okay, let me just add one. Let's add one. Okay, there we go. Okay, so 15%, 19%. So even there, you see, you're going to run into 10,000 probably to get it right. So the sample size must be quite a lot to get it right. Okay,